Hello everyone, this is Steve. Thanks for joining me. We're going to draw a hyperbola. And just like all of our hyperbolas in Math 121 College Algebra, this hyperbola is centered at the origin. When I look at the hyperbola, I notice that the x squared comes first and the y squared is behind the negative sign, so I know that this hyperbola will open like this. The one that's going to make this one a little different than some of the other ones we draw is we have the same number underneath both x squared and y squared. So when I take the square root of 25, I get 5, which means when I draw my reference rectangle, it's actually going to be a reference square, because I'm going to go up and down 5 and left and right 5. So left 5, right 5, up 5, down 5. Okay, draw my dashed lines here. You know, you can never tell from the reference rectangle, whether it's a square or not, you can never tell just from that which way your hyperbola is going to open. We need to know where the vertices are. And the vertices are going to be left and right because that's how our hyperbola opens. So my vertices are here and here. Vertices are going to be at plus or minus 5, 0. Hey, let's find the foci right now. So the foci are found by adding together the two numbers under x squared and y squared. So 25 plus 25, you get 50. You take its square root of 50, which some people are going to say you do have to simplify, and that does simplify to 5 root 2. And the foci are always in the same direction as the vertices. So they're going to be at plus or minus square root of 50 on a 0, or 5 root 2 if you were told to simplify. And that's just a little bit bigger than 7. So therefore our foci are going to be right around here and right around here. One thing we do want to remember though is when we draw our hyperbola, which I'm about to do, is we don't hit the foci, we hit the vertices. So check it out. Like that. And that. Hyperbola is not two parabolas. It's a completely different structure. Okay, what else should we say about this thing? Well, we could say the domain and range. So my domain for this is going to have a break in it from negative infinity to negative 5, and then 5 to infinity. But the range is just negative infinity to infinity. Here's another cool trick. When you're trying to find the asymptotes for this, you'll notice that if we kind of do it the same way we usually do, we go up 5 over 5, but 5 over 5 is 1. And it turns out that if you ever have a reference square, in other words, the numbers under x squared and y squared are the same, then your asymptotes have a really simple equation. So because we're centered at the origin, and because we're going up 5 over 5 for our slope, the slope's just 1, and the other one's negative 1, so it's just going to be y equals plus or minus x. Like that. The last observation I want to make about this particular hyperbola is because we had 25 under x squared and 25 under y squared, our transverse axis and our conjugate axis are the exact same length. So both the transverse axis, which is the one that connects the vertices, and the conjugate axis, which is the other way across the rectangle, are length 10. So there's no rule about which is longer, the transverse axis or the conjugate axis, and it turns out, like in this example, they can actually be the same length also. All right, that's it. Thanks for watching. I hope that helped.